Let's look at an example. So in this example, the strain components at a point in a body subjected to plane strain are epsilon x is negative 680 microstrain, epsilon y is positive 320 microstrain, and gamma xy is negative 980 microradian. As shown in the sketch, you can see that the angle between x and y becomes larger than 90 degrees, so it's a negative shear strain. So the deflected shape of an element that is subjected to these strains is shown here. To determine the principal strains, maximum in-plane shear strains, and the absolute maximum shear strains at the point O. Okay, we can actually use the same principles as in the stress analysis part. Okay, remember in the previous section, we analyzed the two cases when the sigma P1 times sigma P2 is positive or negative, meaning that they have the same sign or not. We have these two different cases, so you can find out the absolute maximum shear stresses. So here we can use the same principles to find out the maximum absolute maximum shear strains at the point. Okay, I will show the details later. Okay, show the principal strain deformations and the maximum in-plane shear strain distortion in the sketch. Okay, so let's solve this example. Okay, the sketch is shown here. Okay, so first of all, we have these strain components. The epsilon x is negative 680. Epsilon y is positive 320 microstrain, and gamma xy is negative 980 microradian. So we already have the equations. Okay, we can directly use the equations to calculate the principal strains P1 and P2 in the same equation. Right, so we have the coordinate of the center. Right, is in the Mohr strain Mohr circle, epsilon x plus epsilon y over 2 plus or minus the radius. Right, the radius we have square root. Inside it is sigma epsilon x minus epsilon y over 2 square plus, okay, here is the important, okay, the gamma xy over 2. Okay, do not forget the over 2 square. Okay. Then just use the values that have been given. We can do this calculation. That is negative 680 plus 320 over 2 plus or minus negative 680 minus 320 over 2 square plus negative 980 over 2 square. Okay, so here you will get negative 180 plus or minus 700 microstrain. So here our two principal strains will be negative 180 minus 700, that is negative 880, and negative 180 plus 700, so you will get 520 microstrains. Okay, these are the two principal strain values. Okay, we can also calculate the maximum shear strain. It is the gamma max over 2. Okay, that is the equals the R, right? Equals the R. We already calculated that here. The R value is here, right? That is plus or negative, positive or negative 700 microradian. Okay. So the maximum value of the gamma of the shear strain will be 1,400 microradian. Okay. Then we can calculate the angle of the tangent 2 times theta p equals gamma xy over epsilon x minus epsilon y. So in the string equation, we do not have over 2 anymore. Okay, keep this in mind. So this will be negative 980 over negative 620 minus 320. Okay, we get this is 680. Okay, so you get 1,000. Then this is 0.98. Okay, can be easily solved. So here the 2 theta p will be 44.42 degree. So in this way, your theta p will be 22.21 degree. Okay, now as said earlier, that we can use the same principles as the stress analysis. So the same principles, the principal side, when the two principles have a different sign. When the two principles have the same sign, the tau max absolute values equals what? It equals sigma p1 minus sigma p2 over 2. Right? When they have different sign, tau max absolute value, absolute maximum shear stress equals the maximum normal stress over 2. Okay, those are the principles we derived last time. So you can use the same principles. You just look at here our two principal strains. Okay, our two principal strains have the same sign or not? Oh, sorry. This here I should have, okay, I need to rewrite them, okay? When they have the same signs, it should have the sigma p1 over 2. When they have different signs, we have sigma p1 minus sigma p2 over 2. Okay, then here, since our two principal strings have different signs, so we should use the second equation. So here's but also keep in mind that the tau max will be replaced by gamma max over 2. Okay, so we will get gamma max over 2 equals the difference between the two principal strings over 2. Okay, so you get 520 minus negative 880 over 2. Okay, that's 700 microradian. So the gamma max will be 1,400 microradian. Okay. So this is actually the same as our in-plane maximum value. Okay, the in-plane maximum shear strain. Okay, if you have the same sign, if the two principal strains are having the same sign, then your absolute maximum shear strain will be different from the in-plane maximum shear strain. Okay, so the same principles as that in the stress analysis. We have done with the calculations, though in the end, let's sketch these situations. Okay, so first of all, we have the original element. Okay, let's see, the original element is a square. Okay, you have, this is the x direction, you have y direction. Okay, then after the the first sketch, we will sketch the principal strains. Okay, the principal strains. Then the principal strain appears when you rotate it by an angle here, 22.21 degree. Okay, you will find the principal strain. So here, this angle is theta p equals 22.21 degree. After this rotation, you will find the principal strains. So along this direction, you will have negative 880. micro strain. And along this direction, you have positive 520 micro strain. Okay. So what is the angle here? The angle here will still be 90 degree, right? Here will still be 90 degree. Because when you have the principal strains, the shear strain is 0. Okay, shear strain is 0, so the angle will keep pi over 2. Okay, it will not be changed. So how about the maximum shear strain? Where can you find the maximum shear strain? To find the maximum shear strain, you need to further rotate it for pi over 4 more, for another 45 degree. Right. So after the further rotation, you will get this point. Okay. So here is 45 degree. Right. So how about this angle? How about this angle? This angle will be we can call it theta s, right? That is 22.21 plus another 45 degree. So you get 67.21 degree. So after this rotation, you will find the maximum shear strain. Okay, the maximum shear strain. So what is the angle here? The angle here will be smaller than pi over 2, right? Will be smaller than pi over 2. That will be pi over 2 minus our maximum shear strain. That is 1,400 microradian. Right, so that is the value of this angle. So let me ask you this question. So at this position where you can find the maximum shear strain, what are the normal strains? Right, you will have a normal strain here, right? Both negative, right? Both negative. It should be the average value, right? This average should be just the average of the two original normal strain values. Right? Those are here, right? So they're average values. You get negative 680 plus 320. You get a 360, negative 360 over 2. You get a negative 180 microstrain. Here also negative 180 microstrain. Okay. Wait. This is a complete sketch of the principal strains and the maximum shear strains.